Hi guys, so for today we're going to talk about Newton's second law, still the application of first order differential equation. We will do two examples for this video. So Newton's second law is actually a famous law formulated by Newton, of which the summation of forces acting along a particle is equal to the product of the mass and the acceleration. Okay, so for this type of problems involving differential equation, okay, if in physics we are considering the air resistance, okay, is negligible, here in first order differential equation, we will be having a resistive force of the medium. We will consider the resistive force offered by the medium. Okay, in physics problem, we often neglect the air resistance. Okay, but in these problems, we will be considering that resistive force. And that resistive force is given by big letter F of our equation. Okay, where F is our resistive force in terms of newtons, plus the mass of M multiplied by the acceleration. Acceleration can be defined as a change in velocity with respect to time, and that is only equivalent to the weight of the body or the particle. Okay, so this equation is derived, okay, based on the free body diagram of the particle, okay, including the resistive force. So let's try to solve some problems. So here is the equation that we need to remember, okay, in order for us to solve first order differential equation involving Newton's second law. Okay, so let's get started. So for number one, a body of mass 4 kilograms from rest or at rest initially from a medium, sorry, this is medium, whose resisting force is numerically equal to 0.003 V, where V is the velocity in meters per second. So letter A, what is the velocity of the body at any time t? So again, we have the formula, resistive force plus M multiplied by dV over dt is equal to mg. Okay? So our resistive force is given, whose resisting force is numerically equal to 0.003 V. So 0.003 V plus M, which is 4, multiplied by dV over dt, or the acceleration, and equal to M, that is still our mass, multiplied by the acceleration due to gravity, 9.81. So, as you can see here, okay, if I'm going to clear this term by simply leaving dV over dt, I could have a linear differential equation. So, if I'm going to divide both sides by 4, so what will we have is we have dV over dt plus, okay, 0.003 over 4 multiplied by V is equal simply to 9.81. And as you can see here, we have a differential equation that is linear in V. Okay? So in order for us to solve that, we need to have, so let me express 0.003 over 4, 0.003 over 4 in decimal. So that is equal to dV over dt, 0.003 over 4, let me just erase this, over 4 would be 0. Oops, this is plus, okay, plus 0.0075. 0.00075 V is equal to 9.81. And if it is linear in V, we know how to solve that. That is V e raised to the integrating factor 0.00075 V is now equal to the integral of q of x, which is 9.81 e raised to 0.00075 V dt. Of course, we have dt also here, and we have dt here. Okay, the v here is not included. I'm so sorry. We don't have v here. That is simply 0.0075. Okay, this is dt. So upon integrating, we have v e raised to 0.00075 t is equal to 9.81 integral of e raised to 0.00075 t, and we have dt. Okay, so let me just not write this first. Let me just evaluate the integral of this. So If we let u is equal to 0.00075t and we get the derivative of that, that is 0.0075, we need the correction factor of over 0.0075 here in order for us to integrate this. Okay? Plus c. So I hope you can follow. So we integrate this. We need to have a correction of factor of the reciprocal of this in order for us to integrate that. So we have b e raised to 0.00075t is now equal to 9.81 over 0.775. 0.00075 is equal to 13,080. Okay? So we have 13,080 e raised to 0.00707. Oops, I'm so sorry. So 0.00075. Okay? T. Okay, that is still T plus C. So dividing both sides by the 1 over e raised to 0.00075 t. Okay, so what will happen? We have v is equal to 13,080 plus c over this value. Okay, so that is the velocity at any time t. But we need first to find for the value of c. So we have the initial condition at t is equal to 0. It says it starts from rest. So our velocity should be equal to 0. So hence, solving for c, we need to solve for c, the value of c. So v is equals to, I'm sorry. So this value of v is now 0 at time is equals to 0. So 13,080 plus c, and this would be 8 e raised to 0. Okay? So technically, we have c is equals to negative 13080. So from this, we have 0 is equals to 13080 plus c. Solving for c, this is our c. Okay? And the velocity of the body at any time t should be v is equals to 13080 plus c, which is our c, minus 13080 over e raised to 0.00075 t. Okay? So if we rearrange this, okay, I can by loss of exponent I can bring this into the numerator. So we have 13080 minus 13080 e raised to negative 0.00075 t, and this is the velocity of the body at any time t. So if we plug in any values of time, we can definitely get the velocity at any time t. So that is our for number A. Answer for letter A. Okay. So for letter B, what is the velocity after 5 seconds? The velocity after 5 seconds, okay, at time is equals to 5 seconds. What is the velocity? So simply, we're going to plug in the value of time here in our equation and solve for the value of the velocity. So we have times 5. And upon entering this in your calculator, you will be having a value of 48.96 meters per second. So that's how we get the velocity. Okay, so let's go now to our second problem. So our second problem, a ball of mass 2 kg is dropped from rest in a viscous fluid. Okay, viscous or viscous. Okay, the resistance of which is 0.001 V Newton, where V is the instantaneous velocity in meters per second. What is the velocity and distance traveled by the ball after 4 seconds? So, okay, so let's write the given. So, again, the formula again, first is F plus M dV over dt. Okay, so we have dV over dt is equal to mg. Okay, so the resistive force again is 0.001 V. plus the mass, which is 2, dv over dt, is equal to 2 times 9.81. So again, if I'm going to divide both sides by 2, so we'll be having dv over dt plus 0.001 over 2 multiplied by v is equal to 9.81. Okay? So if we evaluate 0.001, okay, 0.001 divided by 2, okay, that is simply dv over dt plus 1 over 2000 v is equals to 9.81. So, this is still, again, linear in v. So, linear in v. So, we're going to solve for this differential equation. So, e raised to the integral of 1 over 2000, okay, dt, I mean, is equal to 9.81 integral of e raised to 1 over 2000 dt, and we have dt here. So we have, okay, v e raised to 1 over 2000 t is equal to 9.81 integral of e raised to 1 over 2000 t. We have dt here. So if we integrate this, okay, gonna let this not right first, okay. So if we integrate this, we will be having a correction factor of 2000 outside of the integral because the reciprocal of 1 over 2000 is 2000. So 9.81 times 2000, e, copy the same, e raised to t, okay. We don't have any t here, I'm so sorry, okay. So we are about to integrate that. We have t, okay. We have t because of the result of the integration here. Okay, so that should be t over 2000 plus c. And if we evaluate that, that is v e raised to t over 2000, that is the same of 1 over 2000 times t, is equal to 9.81 times 2000. 9.81 times 2000 is 19,620. Okay, e raised to t over 2000 plus c. Divide both sides by the e raised to t over 2000. So we have v is equal to 19620 plus a c over e raised to t over 2000. Okay? And we need to solve for the value of c. So there's no given condition that in the problem, it does not state that it is at rest, but it is assumed that at time is equals to 0, velocity is equals to 0, that the body is at rest. So we need to find for the value of c. So this is 0, 19620 plus c over e raised to 0 because our time is 0. So this is simply equal to 1. So our c therefore is negative 19620. And therefore we can substitute it here. So we have 19620 minus 19620 over e raised to t over 2000. So this is our equation to find the velocity of the object at any time t. So, but what is being asked in the question? Okay? So, what is the velocity and distance traveled by the ball after 4 seconds? So, velocity first. Okay? After at time is equals to 4 seconds, what is v? Okay, we simply substitute it. So we have 19,620 minus 19,620 over e raised to 4 over 2,000. And our answer should be, okay, our answer should be 39.2 meters per second. So we have answered the first question. Okay? How about the second question? So what is the velocity after 4 seconds and what is the distance traveled by the ball after 4 seconds? The distance traveled by the ball. So we know that our velocity at any time t is 19620 minus 19620 over e raised to t over 2000. Okay? Distance. The relationship of the distance and velocity is that the velocity is actually the change in displacement with respect to time. So, if I'm going to rearrange this, we have 19620 minus, I'm going to put this on our numerator, 19620 times e raised to negative t over 2000. Okay? And we would let this be equal to dx over dt, so that we have dx over dt is equal to 19620 minus 19620 e raised to negative t over 2000. Cross multiplying, we have dx is equal to 19620 minus 19620 e raised to negative t over 2000, the whole equation multiplied by dt, because we have cross multiplied. And if we are going to integrate both sides, okay, we shall be getting the distance x at any time t. So we're going to integrate this with respect to t. So 19620 dt minus integral of 19620 e raised to negative t over 2000. Okay? dt. So, upon integrating this integral, so 19620 times t minus, I can factor out 19620 outside of the integral sign, so we can have this. So, integral. So, if we let u equal to negative t over 200 over 2000, okay? So, we have du is equal to negative 1 over 2000 dt. So, as you can see, I would have a correction factor of negative 1 over 2000 in here in order for me to integrate that function. Okay? So, negative 1 over 2000. So, I'm going to get the reciprocal, that is negative 2000. So, 19620t minus 19620 multiplied by 2000, or I mean negative 2000. And in order for us to integrate this, this is e raised to u du. Okay? So we have x is equals to 19620 multiplied by time. 19620 multiplied by 2000, that's negative, and we have negative here, so that becomes a positive value of plus 3924 and 4 zeros. Okay? The integral of this is e raised to u still. So our u would be negative t over 2000. Okay? Upon integration, we have the constant of integration, c. Okay? So, we need to find, again, the value of c. Okay? And at time is equals to 0, the distance traveled by the ball is also equal to 0. So, applying in our equation, so 19620 times 0 is simply 0, plus 39240000, e raised to 0, this is simply equal to 1, plus c. So, the value of course, the value of x also is 0. Okay? So, because the distance traveled is 0. So, the value of c is simply negative 39241234 zeros. So, again, if we plug this in our equation, we have x is equals to 19620, okay, plus 39240000, okay, e raised to negative t over 2000, okay, minus 39241234 zeros. I can factor out, okay? So we have t here, okay? We have 19620 t here. So x is equals to 19620 t, okay? Plus 39241234 zeros multiplied by e raised to negative t over 2000 minus 1. Okay? This is the distance traveled by the object or by the body at any time t. Okay? And the problem is asking, what is the distance, again, what is the distance traveled by the ball after 4 seconds? So, meaning, x Okay? X would now be 19620 multiplied by the time, which is 4, plus 3924 and 4 zeros, e raised to negative 4 over 2000 minus 1. And if we are going to solve for that, the distance traveled after 4 seconds should be 78.43 meters. Okay? So that should be our answer. Again, we must be careful and we must be know how to solve linear equation and some integration, basic integration, in order for us to solve and fully understand and fully able to solve Newton's second law involving differential equation. So I hope you learned something from today. So this is Engineer Abad. If you are new to my channel, please don't forget to like and leave a comment below, and don't forget to subscribe. So thank you so much for listening. God bless you.